Hello friends, this is paper Electricity and Magnetism C3 CBCS second semester of 2023. In the last video we have already solved up to question number 5. Okay, this is part 5. Here we're going to start from question number 6 and here we're going to complete the paper. Okay, so before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. And if you want to follow me on Insta, this is my Insta ID YAJIT123. That's my Insta ID. You can follow me on Insta. So now let's start with question number 6. Question number 6. What do you mean by the magnetic susceptibility and magnetic permeability? Derive relationship between them. I have already made a video on this topic. This link is in the description box. I have given 6 answer, or maybe I have written question number 6 and then I have given the link in the description box, so you can check the description box. Okay, now let me answer to question number 7a. So state Lenz's law, explain how Lenz's law established the law of conservation of energy. Let me give you the answer directly. Okay, so here is the answer. Okay, to 7a. This is the first page. 7a, this is the first page. This is the page number 2. Pause the video and take the screenshot. Page number 3, and here is the last page. Okay, so let me show you again one by one. This is the first, second, third and the fourth. So now let's move on to the next question. What is the next question here? Okay, there is one more question, 7a, or okay, either you have to answer this or you need to solve this. So how to solve this problem? An EMF 250 volt is applied to an inductor of 10 Henry. It has resistance of 50 ampere. Okay, if the current attains the maximum value, then find the energy stored in the inductance. So let me solve here. Okay, so here it is given, voltage supplied is 250 volt and resistance R is given 50 ohm and inductance is given, that is 10 Henry. So maximum current Imax, let me represent it by Imax. Maximum current will be given by V by R, which is going to be equal to 250 divided by 50. That's going to be 50 ampere. Okay, sorry, 5 ampere, not 50, 5 ampere. That's going to be 5 ampere. And energy is stored by an inductor, that is given by U is equal to half Li square. Okay, so half, inductance is given 10 Henry, so this is here 10, I square is 5 square simply, so here it's gonna be 125 joule. Okay, because 2 cancels, 10 gives 5 square 25, 5 into 25, 125. That is your answer to this numerical, right? So hope you have understood this. Now let me answer to question number 7b. Calculate the mutual inductance of two concentric solenoids. Let me give you the answer directly. Okay, so here is the answer to 7b. Okay, this is the first page and this is the second page, and answer is completed here. Okay, take the screenshot. This is the first page, take the screenshot. This is the second page, right? So now let's move on to next question. So let me take the next question. So next question is 8a. Find the expression for current of a circuit, AC circuit. Actually, I have already made a complete video on this topic. So I have written question number 8a and then I have provided the link in the description box. Do click the link to get the answer of this question. So now let's solve this numerical. Okay, so we have a LCR circuit and inductance is 0.12 Henry and capacitance 480 nanofarad and resistance 23 ohm and connected to a AC voltage 230 supply. Calculate the resonance frequency, maximum current, maximum power and absorbs the maximum power absorbed and Q factor. Those things are to be calculated. So let me write the given informations first. now you see here, let me write the given things. Inductance is 0.12 Henry and capacitance is 480 nanofarad. Okay, 480 nanofarad. Then 480 into, that's gonna be 10 to the power minus 9 farad, right? Then resistance R is 23 ohm. Okay, so and supply is 230 volt, right? Supply is 230 volt. So how to calculate the resonant frequency? Resonant frequency is given by this formula, 1 by 2 pi 1 by 2 pi root over L into C. Okay, so now let me calculate this. So resonant frequency F, this is F. So if we put the value here, 1 2 pi root over 0.12 into 10 to the into 480 into 10 to the power minus 9. So you can multiply, 480 is nothing but 48 into 10, and if you multiply this 10 with this, then what you're gonna get? You're gonna get 48 into 10 to the power, let me write here, 48 into 10 to the power minus 8. That's what you're gonna have. Now 48 can be written as 4 into 12. Here we have 1.2, so if you make it 12, then if you make it 12 instead of 1.2, if you make it 12, then what you're gonna have, if you make it 12, then here we're gonna get, minus 8 to the 10 to the power minus 10, right? Okay, so if you take the square root, then what we're gonna have, 2 pi, here there are 2 12s under root now, so 112 will come out, and square root of 4 is 2, and 10 to the power minus 10, that's going to be 10 to the power minus 5, right? That's what we're going to get. So now from here, you hope you can calculate this. Then what you're going to have in this case, so here we're going to have 10 to the power 5, 2 into 12 into 2 into then again pi. Okay, this much hertz. Okay, then we can write 100 into 100 into 10. So 2 into 12 into 2 into pi. So if you cancel 100 by 4, 2 to the 4, so then you're gonna get 25, and again 3 for the 12, 4, here we're gonna get 25. So that's what we're gonna have, right? So that's gonna be equal to 625 divided by 3 into 10. That is that means 6250 divided by 3 pi. That's what we're gonna have, hertz. Okay, so this is the frequency, resonant frequency. How to obtain the resonant frequency? Now what we need to obtain, now we're gonna find the maximum current, that is E by R, that is voltage supplied, that is 230, divided by the resistance 23, and that's gonna give us 10 ampere. This is the maximum current. Then we're gonna get maximum power is E square by R, so that is 230 square divided by 23, and this is gonna give you 2300 watt, right? So hope you can calculate it by yourself. So 230 square means 230 into 230, right? If you divide this by 223, that's gonna give you 10. So here we're gonna get 2300. right? So now we need to find the Q factor. Q factor is given by root over 1 by r, sorry, not root over 1 by r, 1 by r root over L by C. Now let's put the value of r is 23, root over L is 0.12, then we got C is 480 into 10 to the power minus 9. Okay, and if we calculate this, that's gonna be approximately 21.74, right? That's how we can solve this. Now let's go to the next question. Pause the video first, okay, and note it. Sorry, what is the next question? So here is the next question. State and explain the superposition theorem. Okay, let me give you the answer. So here is the answer to 8b, superposition theorem. This is the first page, take the screenshot. This is the second page, and that's ends here. Okay, so now let's move on to next question. So there is one more question. So 8b or this one. So we have to use the Thevenin's theorem to solve this problem. So let me solve this. So hope you know the Thevenin's equivalent circuit is of this form. So here Thevenin's voltage VTH, and here Thevenin's resistance RTH, and this is the load current, and this is the load resistance R. Okay, this is the equivalent circuit, and you must know these relations. Load current is equal to VTH by RTH plus RL. Before you solve this problem, just note this formula, and RTH is nothing but so how to find the RTH, I will show you later. Okay, first let me solve this. First, our first step is just remove this load resistance. Here we're gonna make it short. Okay, so then what we have got, so we have got the circuit here. This is 18 volt, this is positive, this is negative, and here is one more battery. Here it is reverse polarity, so here it is 12. You can see the polarity of these two batteries are reversed. Okay, so this is 2 kilo ohm, this resistance is 4 kilo ohm, 4 kilo ohm, right? So now first let me find the equivalent resistance. Here we have the point A, and here we have the point B. So you can assume this. Now you see, so if this is A, so you can consider this point is A. If this point is B, these two ends are connected here, so you can consider this is B. So you can consider like this resistance are connected this way. Suppose A, B, this is a parallel combination. You can consider like this, right? Okay, these are the 2 points here. You can see these are the 2 points. Okay, so hope you have understood this. Now this is 2 kilo ohm, and this is 4 kilo ohm. Okay, now let's find the Thevenin's resistance RTH. So how to find that? These are in parallel, so 1 by 2 kilo 1 by, so you have to first write 1 by RTH, then what you're gonna get, 1 by 2 kilo ohm plus 1 by 4 kilo ohm. Then if you take the LCM, then that's gonna be 3 by 4, and RTA is gonna be 4 by 3 kilo ohm, 4 by 3 kilo ohm, right? That's what we're gonna get, RTs. Now next we need to find the VTH. Okay, so how to find it? Let me go to the next slide. We have got RTH. Okay, now let's go to a new slide. So let me draw the figure here. You see, just wait. So now this VTH will be equal to, how to find it? First let me find the voltage at this point compared to B. Okay, this point is A, means this point is A, right? You can consider this point is B. So compared to this point, what is the voltage at this? That means we are going to find a potential difference between these 2 points, right? So that's going to be the VTH in this case. So how to find that? First let me take a distribution of current in this direction, in this direction, in that direction, and this is suppose I1, this is suppose I2, and this is suppose I3. Okay, so here you see, along this path we have no battery sources, so if we ignore this I3, that's gonna be fine. Okay, we can ignore this I3, right? So now you see, so when you come along this path, then you get a resistance, okay, then you get a battery here, right? So now what we need to do, we know that current is the voltage divided by resistance. So here what we can do, so here this voltage, this is 18 volt. Let me consider that potential at this point A, at this point the potential is suppose VA. Let me take this as VA. Okay, then how to find this VA? This VA gonna be the VTH here, okay, because we have no battery along this path. So VA, which is between the 2 resistors, this one and this one. Okay, so how to find that? VA then minus, so when you come along this path, you are going from the higher potential to lower potential, so subtract this 18 volt, okay, divided by the resistance in this part, that is 2 kilo ohm, that means 2 into 10 to the power 3, right? Then plus, then you go to along this, if you go to this part, sorry, not this direction, along I2, in the direction of I2, then this is passing this is going from lower potential to higher potential. So again you have to add 12 volt with the VA, okay, VA plus 12 volt divided by resistance that you have got along this path, that is 4 kilo ohm, that is 4 into 10 to the power 3. That's what you're gonna have, and according to the, so now you see, in this direction, as we have no battery source, just we can ignore this side, so that's why, and this sum of these two will be equal to 0. Okay, that should be taken as 0. Now if you take LCM, then that's gonna be 4 into 10 to the power 3, and here we're gonna get 2 VA minus 36 volt plus VA plus 12 is equal to 0, and this implies 3 VA then minus 24 is equal to 0, and that's gonna give you VA, 3 VA is equal to 24, and it cancels this, then it gives 8. So VA is equal to 8, and here it's gonna be the VTH. Okay, so hope you have got this one. So that's what we needed to find, right? VTH and RTH. This is RTH and this is VTH. So hope you have understood this. Okay, and also we need to find a current through the load. Okay, current through the load, that I is equal to IL is equal to, so what was the formula that I have given you? This is the formula. So here VTH by RTH plus RL. So VTH we have got 8, and RTH we have got what was the RTH? 4 by 3 kilo ohm. So here we can write 4 by 3 into 10 to the power 4 by 3 into 10 to the power 3 ohm. Okay, when you convert it into ohm, then plus load resistance is I think 20 kilo ohm. what was the load resistance? 20 kilo ohm. So it's going to be 2 into 10 to the power 3 ohm, right? So if you write that here, then that's going to be 20 into 10 to the power 3, okay, ampere. So if you calculate this, then you will get, if you take common and LCM and doing all things, and you will get the answer 0.375 ampere. So that is the load current. So hope you have understood this. Now let's move on to the next question. Sorry, what was the next question? Let me show you. Just give me a second. This is the last question. So here you see question number 9. So here you see question number 9 and 9 or both answers are here. This is answer to question number 9. So first part of this answer, this one is that it starts from here, and this is the second piece, this is the first piece, this is the second piece, and this is c theta naught square. Okay, let me write it, half c theta naught square, this one if you can't recognize, and this is I omega square. Okay, so now, and this is the third piece, and the first part of the question that ends here, the first question of question number 9, this question that ends here at the third piece up to this point. Okay, and next question that is 9 or that starts from here, this one is damping, and here you see the last part of this question. Okay, that ends here. Okay, so hope you have understood this. So thank you for watching. This completes paper is completed, so stay connected.